Okay, good morning friends. So today we will have a very brief introduction to what precast concrete is all about. So this is an example of a precast girder which we have here. Now look at this. The piers are separately cast and you are going to have some dowels and there are holes to match the dowels so that you can make both of these together so that they behave like one. So this is essentially what we do. We don't cast it in the place where it is. You have already cast it and you are bringing it to site. One of the biggest advantages is it's done in a controlled environment. It's not done in the open where you know the moisture content is going to vary. Morning the pour will be different. Morning the fellow will be very active, so he's going to put a good concrete. Evening he's going to get tired and sleepy, so he's going to, lose the efficiency and so on and so forth. So this means that there's no variation in the process. Another important thing is that you can adopt advanced curing techniques like steam curing and stuff like that, which is very difficult to do in the site. Not impossible, but it's very difficult. Then you transport it to the place where you want to keep it and lift it and place it into the position. So there are three stages. First you cast it, you need to transport it, and then you lift it and keep it in place. Okay. Now I'll be using precast and prefabricated interchangeably in the classroom. So suppose I say precast or prefabricated, it's going to mean the same. So these are the benefits of precasting. You save a lot on the material. Okay. So the reason is because it's a controlled environment, you don't have to give a higher target strength. Typically what you do, you tend to give a very high target mean strength so that there is that definitely that 5% or whatever is the limit state which you are looking at is satisfied. So this is one of the first and most important things about the precast concrete. So the material which you use is lesser, meaning you are getting thinner sections. Okay, and when you are going to use thinner sections, automatically what happens? The sulfate of the elements come down. But as you make a section thinner, you find that stability becomes an issue. So that's where we design engineers are going to be a little concerned. So these are because of the material benefit what we talked, reduce sulfate, so it means reduce column size, reduce beam size, reduce foundation size. You are going to find that everywhere there is a lot of savings. Okay, you will not be bothered about a very huge foundation. And again, the number of iterations is so many. Look at the number of repetitive elements which they are making. This is for making this tunnel. So there is this tunnel over here. To make this tunnel, they have been using all of these elements. They've been using these elements. So a person who's doing the same thing over and over is going to close his eyes and also probably do the work. So that is one of the benefits here. And again, it will all be without any mistake. And the number of workmen which is required is very few. If you go to the construction site, I don't know how many of you have worked in a construction site before you came here. Any of you? 1 month at least. It so frightened you that you decided MTech is not as scary. Okay, so you'll find that it's very difficult to manage men. Labor force, a large unskilled labor force is very difficult to manage. So here you will find that all of them will be at least diploma holders. So when you go to a construction yard, fabrication yard, very few unskilled people are there. But again, since they are doing the same work again and again, chances of mistake is very, very less. So we are having a concrete which is a high performance concrete. Along with the performance parameters, you also get high strength. So usually you try to, if you look at a cast in place concrete, you try to take self-compacting concrete. Okay, a lot of you here would have done work on self-compacting concrete. How many of you have done work with self-compacting concrete, SCC? Quite a few should be here, yeah? One? Yeah, all are afraid to raise their hands. I am not going to ask you questions. Okay, don't worry. Now here what happens is, instead of the self-compacting concrete which is having a very high slump, here we got zero slump concrete. We got zero slump concrete, very hard to believe, no? So even I found it a little difficult and amusing that you're going to work with zero slump concrete. So we went to a precasting yard. So there what happens is the machine, the precasting, we were looking at the hollow core slabs. So the machine just goes, and what you get is the concrete just staying in place. There is vibration by the machine has a vibrating mechanism, but the machine just keeps going on, and you'll find that the slab is what you expect it to look like. There's no formwork, nothing. So end of the day, once the required strength, cube strength is achieved, they simply de-stress the tendon and start cutting it like a cake. For that also they got a machine. The machine can move on the rails. It has a huge cutter which just cuts it to the required sizes. So that's the thing. Here you got a zero slump concrete instead of a concrete which flows a lot. Again, the strength which it achieves is very, very high, and you also design this in a manner that certain desirable properties like reduced creep, reduced shrinkage of concrete is there. Thermal effects, of course, you cannot do anything, okay, but you can definitely play around with the other two, like reducing the creep, reducing the drying shrinkage. Okay, any idea how drying shrinkage can be reduced? Yes, here steam curing is done. It's kept in a moist environment, so drying shrinkage is automatically reduced. Again, the water content is very, very less, so the amount of water which can evaporate from the matrix itself is reduced. So there's again no chance of drying shrinkage actually happening. You're just reducing some of the things. Again, you choose the aggregates in a manner that creep is reduced. The creep is a function of the aggregate. Okay, what is creep? Creep is the time dependent deformation of concrete. Okay, so essentially it will shrink. Now you want concrete and steel have very good strain compatibility. So if suppose you find that there is a small strain, there's a small reduction in the length of the member, the strain reduces, and proportionally the stress of the bar or the tendon reduces, which in turn reduces the pre-stressing force which you have applied. Okay, so now I'm not going to go into the mechanisms of pre-stressed concrete, but then when you're having a pre-stressed concrete element as a precast unit, you'll find that reduction in creep has a very big benefit. Okay, again, many of the other things, like whatever you talk of high performance, you will find that it is appearing in this particular concrete which you use. Okay, and again, you get the best of both worlds of both the steel and concrete. See, one of the things that happens when what happens to the Young's modulus of steel when you are increasing the tensile, like the ultimate tensile strength. The bars which are used in the tendons are not the same steel bars. What is the Young's modulus of the ordinary rebar, and what is the Young's modulus of the other one? What you're using as tendon? It is the same. Okay, but now I am increasing the cube strength of concrete. What happens to the Young's modulus of concrete? It increases. It keeps on increasing. So it means that actually you are getting a much superior product when you are using these high strength materials together. Okay, again, this is factory made, very controlled environment, so there's very less chances of the variability of the material which is used, and again quality control is very stringent. Every batch of material that comes in is going to be checked. In fact, because it's a batching plant, many of the batching plants can dynamically check a lot of parameters like moisture content, the gradation which is available, so on and so forth. So usually whenever you are sourcing from a fixed vendor, you will find that the properties do not vary greatly. The properties will be more or less similar. Unlike in a site where you can have a little bit of adulteration of other materials and stuff like that. So here the quality control is very good. You are assured of the strength. Okay, especially when you are putting it as a pre-stressed concrete, you are assured of strength. Why? A pre-stressed element has its maximum life load, which it would experience in the life only at the time of de-stressing. So when you are cutting the tendon, the moment you cut the tendon and there is bearing of the tendon with the with the element, that's the time when you got the maximum stress. Of course, I am talking a lot about pre-stressed concrete when I am speaking here, because you will be using a lot of pre-stressed concrete. So under that circumstance, this is applicable. But even otherwise, the strength which the element is going to achieve is very, very high. The strength is going to be very high. Again, the amount of material which is produced by what you call as the outturn of labor is much higher in the precast sections. Okay, when you use precast concrete. So these are the design benefits which you have. When you design an element, you are assured that there is no chance of variability of strength. What you design for will be achieved in the plant. Okay. Again, this we can get actually higher span to depth ratio, specifically when we are using pre-stressing or post-tensioning also. But even otherwise, because the material is very strong, you can make very thin sections, increasing the I greatly. Okay, for instance, these are some of the sections which you can get. This double T, for instance, will have a much higher value of I than any other section. Now, all these sections which you see maybe need not be pre-stressed. But so these are some of these sections which you have. So if you are having a ledge beam, you can keep a slab here. So this slab will be like the floor plank, and you can keep on building on that. Okay. So here, for instance, unlike steel structures, this is having a little bit of weight, which makes it more stable. Again, you can make modular construction, which means that whatever you do looks the same. So essentially, it will be a repeating set of units which you have. So one will definitely match with the other, much like your Lego blocks. Okay. So this is the benefit of going for precast concrete. Again, we spoke about all these three. So all these three, when they are lower, they are going to have lot of benefits. When permeability is low, what happens to the concrete? When permeability is low, you find that the atmosphere cannot go into the material and attack the rebars or the tendons easily. So that is one more benefit which you get when you use the high strength or high performance concrete which are used here. So these are some of the structures which you can do with precasting, and so I'm not sure whether I need to go around with this. And if you see here, this is a prison facility. Usually what you can do is each cell can be made into a module where the toilet, the bed, as well as the whatever else you require in a prison is put in one. The door, everything is one unit. So you construct it, lift it, come and put it into place. You keep on making a series, you get the cells in place. They got the entire kitchen or bedroom put into a module. So once you get the house, in fact, the whole thing can be done as a module. You just lift it, come and place it in position. Okay. So you will find that there are a lot of videos on YouTube which show how precast houses can be very quickly done. And even in India, we are having about 15-story buildings and all which are precast, which are being done now, and the time which it takes is less than 5 weeks. Time which is taken is less than 5 weeks. Okay. So you just think of some of the elements that can be precast. Roll number 14, just a random number. Yes. Okay. Any element which can be precast? Okay, beam elements. Roll number 45. Yes. Beam. Columns. 32. 36. Slab. So hollow core slab, which we talked about, and 14 I told, 14, yeah, 14, okay, 12, roof, okay, slab, okay, there's not much difference. So you see, your lintels are one of the most commonly used precast elements which are even done in a regular construction site. You just have to cast the lintel. When the brickwork is done, as soon as it's done, they just place it and then they go on. So lintel, sunshades, Your railway sleepers is one of the biggest consumers of precast elements. Your electric poles, transmission line poles, those are also things. So almost like right from the foundation till the roof of the building, you can have precast units. So we've got examples where the planter boxes are also made along with the structure and put. And in Hyderabad, one of the clubs wanted it to have the Nizam style of architecture. So the windows also had that arches and stuff like that, cast in the site itself, and then they took it. And these are some of the elements which you do. One of the things is that you get to repeat the same element over and over again. So it means that the lifting principles are the same, the transportation principles remain the same. Once you are able to fix the road, which road you are taking, so you will find that you can just standardize a lot of sizes. A lot of sizes can be standardized and you can just take it. What happens is the curve of the road is one of the principal things which determines how long an element can be. You will be seeing a few slides later on where you can actually see the challenge there. And again, the heaviest axle load which can be permitted on a road also needs to be known before you start to send a prestressed precast element. Okay. Now this is a precast warehouse, which like yard which is there. It's a very controlled, closed area. Now this challenge which we have is precast concrete is a manufactured product. So you may have to add GST, VAT, you name it, into the product. It increases the cost. Okay. Then again, as we are talking, there are transportation challenges. The design challenges that the design is just like any other design. There's no difference, but the connection is the very important part. We have to be very careful about the connections. The connections can be suited, made to what you would like it to be. If you want it to behave like a shear connection, then no moment will be transferred across the section. But this being a simple span, you will find that the deflections are larger. So as a design engineer, you will have to balance quite a lot of things, and especially the connection is the most important or most challenging element. For instance, there was a ramp which was used as a case study in one of the courses which I went. So they were telling how it was a challenge that the same connection is going to come at different levels, and how you are going to ensure, like you need to design one element, one connection which will be suitable for all the parts. Some of them will have more horizontal loads, so on, and other challenges. So you need to be very judicious in your connection design. Okay. And again, there is something, the behavior at various stages. So if suppose you are taking a precast element, it is being cast in one place, so it is going to endure a lot of rough handling. There is a difference between carrying a beam like this and carrying a beam like this. What is the difference? Value of I is different. So because of that, deflections can change. The sulfate is the same, but because the deflection is more in one case, you are going to find unnecessary cracks. So and again, one more thing is when you store and transport also, there is a different kind of load. When you lift it and place it into position, it undergoes a different kind of load. Once you place it, suppose it's post tension, you may apply some post tensioning to reduce to counter the self weight. Usually pre-stressing takes care of the self weight, and post tensioning is used to counter the dead loads which come. In fact, the video which I have will show you very clearly how this camber is formed in an element. We will have it in the next class. So there are the stages. So the design engineer should be a little familiar with how the element is going to behave during its various stages of life. Okay. Again, at various stages, what happens is some of the parameters are time dependent, like creep. Okay. So how is creep going to influence over a period of time. So these are some of the things which probably as a design engineer you need to go into. Okay, so these are the benefits of precasting. You find that it's in a shed. The shed, being in a shed, it means that whether it's raining outside or whether there's snow or very heavy, it's the peak of summer, it's not going to affect the process. You can change or modify and control the environment in which the precasting is being done. Okay. It is more sustainable than conventional construction because the amount of material use is lesser. Okay. Again, if you take the case of cast-in-situ, wastages will be much higher than what we have in precast yards. Okay. So again, because you are using modular construction, there's a lot of reuse of formwork and other elements which are associated with concrete. So it means that it is automatically getting optimized. Again, affordability is depending on how close the precasting yard is to the final site. So it can be cheap, it may be costly, but sometimes they are willing to transport over long distances for the sake of time economy. Okay. Again, its durability is much more than ordinary concrete, but then I put a question mark. Why? If you are not having a proper connection, you are going to find that there is going to be the regular problems. There may be water seepage, permeability, durability issues could come. Okay. Then it is healthier only because unlike in the yard, you don't have much of the cement flying. You won't see any cement dust flying and all that sort of stuff. It's relatively much cleaner atmosphere environment in which you are working in. Okay. And again, the amount of water which is wasted or spent on curing and all these things is very, very less. Again, if suppose there is a case like tsunami and stuff like that, you will really find that you can design a small shelter and very rapidly take it to site, and you can take it very rapidly to site. Okay. So these are some of the engineering benefits. See the window, door, you name it. This is a staircase. These are some of the beams. Okay, or can all be done in one single element. They can all be done in the factory, taken and just assembled, and you can give a variety of colors to the concrete so much so that you don't have to go and give a finishing layer. You don't have to worry about plastering. Already it is so good, the surface is so good that you can start on the work directly. Okay. Again, you can get whatever is the required acoustic performance or the thermal insulation, and also vibration control. Like vibration is based on the stiffness of the entire structure, so you can probably modify the stiffness by using your post tensioning or something, and you'll find that the vibration is also much lesser. When you are saying fire resistant, it's much more fire resistant than steel. Basically, that's the only thing where we can really look at it. Okay? And again, as we are talking, connection is the challenge. It's very difficult, and you are going to deal with slender sections, and slender sections have a tendency to buckle. Okay, so you'll have to think of keeping diaphragms at suitable distance so that it doesn't tend to warp and fail. Okay, again, lifting and placing is a challenge. Okay, can you see this girder? Of course, this is not in India. I've all taken these images from Google. Okay, and one thing is precasting is very is now almost like a very well developed and mature thing in America because of the amount of research which is going on. They do full scale models and then they work out the design formulas. It's not empirical, so it's all if it works in the lab, it is going to work in the site, just like that. Okay, so you can see the spans which are being transported. Of course, again, the road has to be amenable for transporting such huge sections. These huge sections can warp and buckle even when they are in transit. So it requires a lot of care when it's being transported also. Okay, so you can see the huge trucks which are being used to transport these precast elements. Again, can you see this is a very funny launching girder? This is done in China. Okay, this is an actual launching girder which was used. So actually a lot of ingenuity also can be coming into the picture. See, this is the lifting arrangement inside a casting yard, and here there is another lifting girder for lifting the precast units. Okay. Usually these type of A-frames are called Goliath cranes. So they can move on tracks. In this case, it's moving on rubber wheels. So you can load. You can just carry the element, bring it to the truck, and place it on the truck. Okay. Again, here you see this is lifting and placing of the girder on site. So usually what happens is one of the companies which gave us the which was sharing their experience was telling that almost 50% of the works or the inquiries which they get for a precast construction are rejected only because the site is not amenable for precasting. The site cannot accommodate precasting work to be done. That is, you need sufficient space for stacking, sufficient space for lifting. A crane is crane requires certain amount of space, working space around it, so that it can have the booms, luffing booms, and all that, so that when it's lifting, it will not topple over. Okay, so they are forced to reject many of the cases also because it's not amenable. Site may not be amenable for precasting. Okay, these are some of the Indian codes which we have. Please go through, especially this 591615916 and the others. You will find that there are a lot of terms which are associated with prefabrication. I am not going through these terms, mainly because it will be a little boring for you guys if I keep telling the same thing. So this is a project in Kuwait, so you can just have a look at how things are being done. This is not, at least as of now, I don't think it's fully complete. So you can see the, if you have a closer look, you'll find that the connections, there are ducts for connecting the elements. Usually this diaphragm which is placed at the end, okay, and the rest of the elements will only be hollow. So these box sections, they are very good in resisting torsion also, which an I-beam is not really capable of. Again, if you look at the thickness of all of this, they are very, very small when compared to the size of the element. Okay. If you look at the PCI handbook for bridges, you will be amazed to see the web thickness. In fact, it seems so negligible. And now prefab has come to that level that steel industry is taking clues from prefab as to how to have effective connections. Because prefabrication, these prefabricated structures are such a major force of competition in US. Only because of the amount of research which has gone in. In India, we are not having that much of research, and also we have the challenge that many of the roads cannot accommodate these huge trucks. Okay, just imagine in Vellore, if a truck goes like this at a very slow speed, you will find that the entire city is thrown out of the clitter. Okay, and again you need very special launching girders. In Chennai, one of the launching girders failed, killing a person. It was very close to my house. Probably I can bring some, I have some photographs of that. So the launching girder failed because they didn't keep the counterweight. So that's of course a thing which is a point of sight, say sight issue. But still, as a design engineer, you need to think about what could happen, what could go wrong, and is it going to be safe for the launching girder also to handle. Again, you see amount of economy we are trying to achieve. These are all castellated girders, meaning girder also reduces its weight, and also the amount of material used is far lesser than any other. Okay, so this is a finished portion of the same project. Okay, so with this I am closing today's lecture. I hope you found it useful, and this is what we are going to try to develop, or try to get our hands a little dirty and try to design a few elements. please remember, designing a precast element is no different from a normal element. The only difference is that here the connection determines how the rest of the assembly is going to behave. Okay, so I'll just give you a little opportunity to ask questions. Any questions, please?